Hello and welcome to the Open Systems Media eCast Balancing Software Requirements and Test Needs. I'm Kurt Schwader, your moderator, with today's speakers Vance Wilderman from Vector Software and Jerzy Wallach from Polarion. Today's schedule consists of about 50 minutes of presentation material, leaving 10 minutes at the end of the hour for audience Q&A. Before we begin, I'd like to run down some important features of your viewing console. First is the Enlarge Slides button. This button will maximize the slides to fill your entire screen. The Download Slides button allows you to download and print the slides if you'd like a hard copy to follow along with. The button labeled Forward to a Friend enables you to send an email to someone that will include a registration link to this eCast so they can also attend.
I'm on.
The Ask a Question text box enables you to participate in today's event. You can simply type your question into the box and submit it using the Submit button. You can submit questions at any time during the presentation. We encourage you to do so early and often while you're looking at the material in question and it's fresh in your mind. We'll address as many of these as we can during the closing Q&A session. And if you have a question pertaining to the eCast operation itself, you can submit those too. And one of our technicians will be happy to respond to you during the eCast. We have a great presentation for you here today. We have two speakers. The first speaker is Vance Hilderman. He is the Director of Global Services for Vector Software. Vance has a rich 25-year history focused on safety-critical avionics software systems and hardware and related technical products. He's considered an expert in safety-critical software and computer systems and certifications, having consulted with 95 of the world's 100 largest aerospace companies. Vance is the author of the world's best-selling book on avionics development and certification, published by Avionics Communication, titled Avionics Certification, A Complete Guide to DO-178B and DO-254. Our second speaker is Jerzy Wallach. He's the Vice President of Product Management at Polarion. He brings 10 years of experience in software product management and engineering, where he's responsible for the product roadmap, product management. His unique mix of technical acumen and business savvy enables him to translate market needs into enterprise-grade solutions proven to help customers accelerate collaboration and innovation. He has a track record of success with user experience and satisfaction, as well as software development and architecture. Jerzy holds a master's degree in mathematics from the Charles University, Prague, Czech Republic. Vance will be kicking off today's presentation. Vance, the floor is yours.
Thank you very, very much for that wonderful intro. Everyone, good morning, good afternoon, good evening, but not yet good night. We have a great Polarion Vector Software webinar here for you here. It's going to go fast, 40 minutes, but we'll have plenty of time for your questions. If we don't get to all your questions, there'll be protocol for sending us an email, and we will follow up with you. This first slide, shall we begin? We like to begin with a little quiz. Can everyone see that first slide? How are you with requirements and testing today? Let's begin with a little quiz. It's simple, 50-50, true, false. Just a few questions. We'll answer these questions in another 40 minutes near the end of this webinar. First one, true, false. It's best to develop software and tests without detailed requirements. Number two, it's common to develop software and tests without detailed requirements. Number three, tracing layers of requirements to test is tedious and difficult to maintain. Number four, it's better to first develop the software followed by the tests. Testing has completed the software to save time and avoid tedious test updates. Number five, testing software directly and immediately improves software quality. Okay, let's see. You know, I lost my internet connection. Can my moderator push the next slide for me?
Sure can.
Fantastic. We'll just do it this way. I think that internet connection wasn't tested with Vector, at least on my end, and Polarion software. So we're standing by to see that next slide. Let me know when that slide 3 is up.
We are. It's there.
Oh, fantastic. So we just took the quiz. And now, real quick intro. Vector fully complies and satisfies the V model of testing, from requirements to architecture, system design, all the way up to unit testing, integration testing, and system testing Vector is there for you. We have complete solutions for the whole gamut. On the next slide, we look at our software tools and professional services real quick. Vector has deep domain experience in software test tools. We really promote continuous test implementation, and that's terrifically integrated with Polarion, as you'll see. We do on-site training, project consulting, best practice workshops, and we do a lot of industry standards compliance and, of course, outsourcing of testing. Let's look at that next slide. The yin and yang of software requirements and testing. Let's think about this. Which would we rather have? Good software requirements or good software testing? It's an interesting question. Most companies focus on one or the other. But truly, for efficiency and quality software development, the answer truly has to be both. We need good software requirements and good software testing, but those are a yin and a yang, okay? Let's look at the next slide. Traditional software development has separated the requirements and the test process. Traditionally, companies follow a waterfall method where the requirements are developed first, then the code is developed, then somebody writes, then executes the tests. Okay? That was good at one time, but let's look at a little different approach. Look on the next slide. Traditional software products really don't work in today's market, because today's products really can't follow that tradition like we used to do. Today we have a need for a faster time to market. We truly have software with exponentially increasing complexity, and we have a rapidly changing software requirements that have to respond to a very dynamic market. If none of us have competitors and we can keep selling the same product for the next 20 years, this doesn't apply. But if you dialed in today, that is not your market, that is not the real world. Let's look at the next slide. Today, success truly needs a yin and yang integration of requirements and tests. The reason for that is it allows us to have earlier definition of software architecture, early definition of test cases and requirements, earlier correlation of tests to those requirements. That's the traceability, and Polarion teaches really well how that works in a real world. Number D, earlier requirements management, and finally, continuous testing of this process to refine it, to perfect it, to assess defects as we go, so instead of correcting defects later, we're preventing them today. This is that yin and yang of software requirements and testing. On the next slide, start with requirements. First, truly, software requirements are the foundation of software success. The majority, and we hate hearing this as developers, we know, but we are blamed. The majority of software errors are due to our weak requirements. So we should plan the testing of software while we're developing those requirements. How do we do that? The next slide. The test planning begins with assessing the requirements to understand them. Assess the testability. Then assess, is there any ambiguity? How would I test and trace to the test while I'm writing requirements? If you, the tester, do not fully understand the ramifications of those requirements, ask yourself, how could the software developer do so? So improve and clarify that requirement by writing the test before you write the software. So determine what should be tested and then how it should be tested. On the next slide, we can see an example requirement. Let's take a look. We have a system-level, high-level black box requirement that electrical power, for example, shall be regulated and include a backup voltage regulator. Okay, it's an important electric power regulation, so we have a backup. The high-level software requirement might be, first, have the voltage regulation system, the VRS, continuously monitor the primary power bus voltage and determine if that voltage is within a valid operating range, and see that that requirement is uniquely tagged. Then ask if the VRS software, voltage regulation system, determines that the primary power bus is either above or below the valid operating range, then the backup voltage regulator is assigned to take over the role of the primary, a simple switchover. And that one's unique to TAG also. Let's look at the next slide, slide 12. Then the detailed low-level software requirement, to really clarify, would say the valid operating range is 24 to 28 volts, and that's uniquely tagged. And then when the backup voltage regulator becomes primary, we send a message to the ground station, uniquely tagged. There's a derived extra requirement. We have determined as engineers that if the voltage regulator isn't healthy and the primary power bus isn't within the valid operating range for more than 3 consecutive queries, then we should send an alert to the operator. So that's an extra detailed message. We write all those requirements. We think about them as we're writing the tests, folks. We're tracing those requirements to the test so the developer gets it right the first time. Looking at the next slide, it's really important to avoid giving in to temptation. As humans, and we're all dialed in as humans today, we're online, we know human instinct, especially for smart engineers like you, after all, you all dialed in, tuned in, so you are smart. Our temptation says, go ahead and test those weak requirements, get something done. But wait, hold on just a minute. Do smart engineers always give in to temptation? The next slide. No, we don't. We avoid temptation. Those might have looked like good requirements, but they need to be improved first. Ask yourself, for that last quick example on 2 slides, are those requirements fully testable? Were they deterministic? Did I rely on certain assumptions? And assumptions is the #1 cause of software errors. Might 2 different software developers implement them differently? Finally, if you cannot unambiguously determine the expected intent of those requirements, how could the developer have written code? So we must improve those requirements first because many, many assumptions were unaddressed. Let's take a look. This is not a detailed requirements course. We have those. But take a look. There were some questions here. Did you notice these? What happens when it's over voltage above 28? If a single instance of over voltage, does that trigger? Remember, we said 3 queries before on the lower voltage. Same as under voltage. What determines health? We said if the backup or primary is not healthy. What is the definition of healthy? These alerts that we generate, is there a priority? What are those priorities? How often is the voltage monitored? What's the resolution accuracy? See, if we don't answer these questions, folks, the developer could make mistaken assumptions, and then where are we? So the key is to ask yourself, could 2 different developers read the same requirements and get different assumptions? Okay, the answer must be no, and the way we do that is by having automated traceability and continuous testing. How? Well, remember, the next slide, slide 16. The best practice is improving the requirements by testability. Okay? The traditional approach, software developers receive weak requirements, make assumptions, and implement the code. But a test-driven approach with Vector and Polaria would say, software developers develop those test cases via VectorCast in parallel with the software development. Why is this better? We improve the requirements before the incorrect implementation. We avoid those assumptions. Preventing mistakes is much better and much cheaper than fixing mistakes. After coding, use the structural coverage metrics via VectorCast to assess requirements clarity and test case quality. Folks, if you've executed all of your requirements and you find that you cover 60% of all the branches in your code, you should be asking the question, where did the other 40% come from? But the key is knowing how many of those structures or branches were uncovered. You need structural coverage, such as Vector, in order to do that. Looking at the next slide, we'll turn it over to traceability with Yuri Wallach, who will dive right in and teach us how that works in the real world. Yuri, all yours.
Thank you, Wes. It was a great intro. So before I start speaking about traceability, let me just very quickly introduce Polaris Software. Polaris Software is a leading innovator in application lifecycle management solutions since our first product release in 2004. It is a 100% browser web-based solution with one single unified artifacts repository. We cover all phases of application lifecycle management, from requirements through design, development to verification. And the seamless traceability is a key differentiator of our solution. But I do not want to speak about our features today, but more about traceability in general, the key concepts, and as well as common undervalued practices. But first, let me clarify a bit how one can define traceability. Too often it is considered just as the ability to link items together. But traceability refers to the completeness of the information about every step in the supply chain. In simple words, if you speak about requirements and tests, traceability is not about having a link between a requirement and a test, but ability to show how were the requirements really tested in time of the release. So the first core pillar of traceability is so-called historical traceability. It means the ability to understand, who, what, and when for any change. Every single change must be identifiable and accountable. The prerequisite to have all the changes accountable is that you need to uniquely identify every artifact. In case of requirement specifications, it's not just the full document, but every requirement, is more or less every paragraph in the specification, needs to be uniquely traceable. Very often regulatory standards requires not just the data, but also process configuration to be versioned and validated. It is absolutely necessary that the solution is fully automated. Here, FDA had sent a warning letter with a reason: failure to maintain adequate device history records. One design history record contained an inaccurate date. One design history record with an inaccurate date. In the rest of the presentation, we will speak more about cross-artifact traceability. Even if it is not simple to automate as historical traceability, it is a key for your success to set up the environment that where maintaining traceability is as efficient as possible. So, process traceability. The requirements are clear. Organizations has to follow the design and development process that ensures that devices meet user needs, intended uses, and specified requirements. So the inputs must be documented, outputs must be documented, and you have to confirm that the design outputs are traceable to design inputs in a form that enables verification. That's easy to say. But one of the most common reasons we see why the customers fail is the scale of their projects. The software projects are getting more complex every year. You can read about just 20 million lines of code for just a multimedia system in a modern car. Other reports about exponential growth of the software project. Actually, a lot, if not most, of the innovation these days happens in the software part of the product development. We see that the complexity of such projects are heavily underestimated. We can start just with linking between system and design requirements, where the industry standard is a common concept to verify the traces, but frankly, who can really read such metrics with thousands of lines and columns? But even more important, the modern ALM systems, such as Polaris ALM, can really manage the full process flow. But anyway, the customers are using diverse complementary products for system modeling, such as MATLAB Simulink, for software UML modeling, for example, Enterprise Architect or IBM Rhapsody. And of course, then the CAD drawings can be stored in Perforce, source code in Subversion. So there is really a different set of tools being used. Understanding an impact of a change just by following the links is horribly expensive. And there are several other vertical pressures that just extend the complexity. The number of requirements is huge and getting bigger every year, but also the number of changes required to be processed is largely increasing. At the same time, the quality and functional safety requirements are getting stronger. Let's just take as an example ISO 14971 that has already been applied in the EU, but not yet in the US. That requires the possible risks to be fully mitigated instead of as low as reasonably practicable, which removes any space for economic considerations. So you need to ask and optimize how much effort you spend to analyze and make a change, implement, analyze. There is an ongoing discussion how much you need to actually synchronize the data between different solutions and how much you can rely on the data to be just linked. We find it very important to publish, you can say also synchronize, necessary information from one system to the other, of course just enough information to help you with instant analysis or verification. To stay practical, the system model in MATLAB Simulink is not just linked with the system requirements, but the visual representation is published to the design requirement specification document so you can analyze the impact of a change to a system requirement in the same environment where you change the actual design requirement. In the development process, the source code is the most downstream traceable artifact. To summarize, you need to prove that all the documented requirements are implemented, but very often bottom to top, only documented requirements are implemented. It means nothing else but the documented requirements are implemented. So every source code change must be traceable to a requirement. And again here, we need to highlight that you cannot simplify it just by linking the changes to a few high-level tasks. The traceability refers to completeness of the information. As you can read here in this testimonial, where a customer is reporting about their DO-178B audit, they had to show the changes to a source file match the description of a changes document in a change record. It's not just checking that you have a full coverage in the traceability metrics. It's really to give a proof that the changes are matching the descriptions. As always, you cannot really automate or derive the relation, but you can implement a workflow to control the process consistency. It means that, for example, developers would be able to check in the changes only if they link the task that is assigned to them, that is still open, planned for current release, and link with requirements that are approved. So finally, speak about verification of a system and design requirements. The requirement is clear, provide an evidence that the requirements have been approved, implemented, and verified. As it's source code, you can hardly automate the content creation of the test cases, so the test cases are automatically generated, but you can set up the workflow that enables to control the test coverage better, and especially that the changes are processed in time, not postponed. As an example, when the requirement needs to be changed, you need to reopen it, and this marks the already linked test cases as suspected. And you have to process all of them before you would be allowed to mark the requirement or change as complete. There is another common scenario that adds more level of complexity to already large scale of the software projects. Based on our survey, organizations didn't rely on a single provider of testing tools. Even though all the ALM vendors provide such a solution, customers combine best-of-breed solutions for testing. To automate requirements and test traceability, you need to automate the process of importing all your testing procedures into unified quality and test management solution. And moreover, as we said, you need to import not just test procedures, but also the test results that are by definition detached from the test definition, as the same procedure needs to be executed often in different conditions. So you can really prove that the tests were executed, so you can prove that the requirements were really tested. Let me show you how one of our customers, Fujitsu, has organized the source code quality assurance. It confirms, that Fujitsu, same as any other organizations, do not rely on one single vendor of quality assurance tools. And we see that the continuous integration and testing also includes other elements such as static source code analysis or code metrics. You can also see here, that we have the integration between Polarion and Vector software, and we bidirectionally synchronize some of the information, not just link. So all the results are imported into Polarion and transparently available to all the stakeholders. It's not only to give a proof that the verification routines passed for regulatory bodies, but also to simplify the access to the results and speed up the process. For any kind of a test failure, the issue is automatically created and assigned. It massively reduces the time to start working on the issue, and you probably know that there is exponential dependency between time to fix an issue and time when the issue has been assigned to be fixed by developers. It is a big difference if you just receive an email or if the task appears in your task list, possibly automatically linked with the requirement that caused the issue. This might save even several days, comparing to situations that the email have to be manually processed. This introduces me to the last topic I would like to briefly touch today, and how does it really relate to Agile? You're speaking a lot about requirements, design, development, verification, about the V model, but as Vance was already saying, it's inevitable to go Agile and be ready to embrace a change, to do frequent releases. And to do so, you really need to adopt some of the Agile practices like continuous testing and automation. Agile methods have been definitely proven their ability to increase project success, and the fairly wide adoption of several of them, like Scrum, proves that most of the principles behind Agile are valued by customers. So, even more, we have a practical experience with functional safety standards in Agile. You are working with TÜV Nord, a German certification authority for ISO 26262 for functional safety in automotive development, because the Polarion is actually the only fully featured Aon solution qualified as a trusted tool for ISO 26262. And as we work together face by face, they share that Polarion is the first company they certified that was actually practicing the Agile methodology, namely Scrum, to the full extent. The outcome of the certification was that it doesn't matter much when is the documentation actually written, but that it exists and it covers the full scope. They also liked on Agile the way how the software is built incrementally with continuous verification, reducing the number of functional changes, as we said, because as they shared, the most common reason for a functional issue is not that it was developed wrong initially, but as some functionality was later changed without noticing that it impacts other functionality. So their requirements were that we had to demonstrate that the software units fulfill the software specifications and do not contain underserved functionality, that requirements were documented, that we have documented verification scenarios that are traceable again. And of course, they were also asking for source code changes to be linked with the actual user stories and requirements. And when adopting Agile, it is essential to understand the difference between requirements and user stories. It's not simply possible to rely on the software code itself and individual understanding of the product as the only way for the project documentation. So you need to start speaking about complementary documentation, for example, component specification documents. The primary reasons for those specification documents is to manage the complexity of your projects and also ensure consistency, not just functional consistency, but also the design consistency, the user interaction consistency. There is no way you can do it for a project with 20 million lines of code without any kind of the complementary documentation. what is though important for those specification documents is that they are maintained when done. On the other hand, the backlog concept, the power of the user story to describe the increment, it clearly describes the story and the value it brings for the user. This is really great. But what is important is that you can almost discard the user story when they are implemented, when they are verified, as they really describe just the increment, and there can be just another user story that completely overrides the way how the feature is being exposed to the user. So how it actually works together. So very often, I mean, there is some kind of a funnel on the top that brings the business plan as an input. The business plan is, of course, an optional artifact for some kind of projects, and it's really likely just a nice mental exercise for product managers. And then you might have some epic requirements. It is much easier to gather the initial requirements in a structured specification document and then translate them into user stories. As the translation from the requirements into user stories or work packages requires really some very special skills to be sure that they are small, not overlapping, and feasible to implement. This can be gathered from the field, from all the different people who provide the input to the backlog. So once the user stories are in the backlog, they are prepared to in a different scope. On the bottom, I have the big, roughly written stories. And on the top of the backlog, there are well-formulated, small enough, and estimatable stories just ready to be planned to a sprint. The component specification, or even the system specification documents and design requirements, provides supplementary documentation for the user stories to ensure the product consistency. There are two possible approaches here. Really have the component specification just a document how the product works just now, and document the changes once they are really implemented. Or you can also do some analysis performed before, often together with definition of test procedures before the actual implementation starts. But what I need to highlight that as well as it is important to have the real potentially shippable product as an outcome of the sprint, it is important to ensure that the product documentation is updated, so the component specifications are the outcome of the sprint, as well as the code and updated product backlog. So this is what I was saying when we were working with TIFF for our ISO 26262 specification. It doesn't really matter much, I mean, that you do requirements first into the full extent, but you have to be sure that all the activities have been performed latest at the end of the sprint, and everything is fully, consistently documented. We are speaking today a lot about automation, but also about efficiency, as well as complexity. And you know, when you define your process, be ready that your project spans over months and if not years, and there will be a lot of data to be managed, a lot of versions and plans. You can start fast as Irene against Martina on the last Olympics, but more important is to keep the speed, keep the velocity over the full project, as well as Martina was able to keep the pace, keep the momentum, and keep the same speed over full 5,000 meters, so she finally won the gold medal on Olympics. And that, I mean, reminds me of other quote, for every complex problem, there is a solution that is easy, simple, but wrong. So don't underestimate, I mean, the complexity of your projects, the scale of the data you need to manage, and really design the process that really enables to automate as many routines as possible and to configure all the team interaction in the most efficient way. Now I hand out to Wens.
Well, thank you, Yuri. That was a terrific presentation. Folks, there was a lot of terrific, valuable information from Yuri there. I hope you're able to catch that all. It's really good. Now, Yuri led into the key of traceability. Truly, it's the center stone or the Rosetta Stone, the foundation of software quality, whether it's agile, whether it's structured, whether you're high reliability or consumer software. Weak development truly has weak traceability. We need to recognize that traceability is our friendly receipt. It proves that we had a transaction. It proves that you planned your requirements or your user stories, another version of requirements for Agile, your design, your test processes. It proves that you implemented and verified all those requirements or user stories. It proves that you can readily regression test, okay? How many of you have software that is perfect the first time and never has to be changed? Folks, if you have perfect software, bless you, but if you have a good product, it will be updated because the consumer, the market will demand it. That means you need regression testing. That means you need automation. That means you need that traceability to be automated as well. So some recommendations for that. Several of them. First, implement an automated traceability routine. Now, use Polarian, for goodness sake. Integrate traceability into the review and the test processes. Again, whether it's Agile, whether it's a waterfall, do it in a continuous basis and integrate that traceability into that whole process. Automate your requirements, testing, and traceability so it's always updated and accurate. That's that continuous testing that we're talking about. With that, let's see how we did. 40 minutes ago, we had that quiz. Time flies. Let's look at the next slide and answer those questions. Okay? The first question. It's best to develop software and test without detailed requirements. Of course not. That would be false. It's common to develop software and test without detailed requirements. Folks, unfortunately, that is true. Not a good thing. Number 3, tracing layers of requirements to test is tedious and difficult to maintain. Yes, if it's done manually, but no one does that today, not with these tools. It's false. The tools do almost all the work for you. Finally, number 4, almost there. It's better to first develop the software followed by the tests. Test the completed software, saves time and avoids tedious test updates. Well, it might avoid a test update. It does not save time. Remember, the goal of testing is to assess the goodness of software. We want to do it continuously, automatically, with traceability throughout the process. Finally, number 5, testing the software directly and immediately improves software quality. Folks, when I was a teenager, I had an old car. If it was possible to test that old car and turn it into a brand new Ferrari or Mercedes, I would have loved testing in that way. Testing is a valuable tool to assess quality, to improve quality with a feedback loop, but it's part of the feedback process, okay? Testing doesn't directly improve and automatically improve quality. We need that process to improve the software as we go, and that's been the purpose of our Vector and Polarian webinar today. With that, I'd like to turn it back over to our moderators who will take your questions. Looks like we are right on schedule.
Fantastic. Thank you very much, Van and Yuri. We are now to the Q&A portion of the event. We have some questions coming in, and again, we ask the audience to keep asking those questions while we have the experts on the line here. Looking at these questions, it looks like a lot of them are revolving around Agile and mapping what your discussion was. I think we're going to end up having a little mini roundtable on Agile here. So let's start with the top level with Vance. If people are using Agile methods, how do they reconcile balancing requirements and testability in the context of Agile?
That's a terrific question because more and more we do see Agile. At one time, as recently as a couple years ago, folks thought that Agile and high quality were like oil and water. There wasn't a yin and yang. But in fact there is. There's much from Agile that we can learn, okay? Some of the challenges with Agile can be, and that's what this question probably alludes to, the fact that we can have changing requirements more rapidly. We have less documentation of requirements, and perhaps we have a prioritization, a somewhat subjective prioritization of requirements. And all those things are good. It's a normal, healthy, Agile lifestyle. However, that mandates the need for that traceability, okay? And it mandates the need for automated traceability. The traceability will ensure that we don't lose track of requirements, that while we have gaps in our knowledge or by deferring requirements or having lower priority requirements, we don't let them fall off the table or the edge of the universe, as we say. We use that traceability to ensure that the testing is either updated automatically or the automated traceability indicates it needs to be updated. And so that traceability really becomes the cornerstone. That means we more and more need the automated testing and the automated traceability, hence the yin and yang of Polarion and Vector software here. So with Agile, if we try to do it manually, we would need a Mensa, international genius organization with IQs higher than mine in order to track them all. So it is possible to use automation, continuous-based testing, and make that traceability the cornerstone of your Agile centerpiece, if you will. Thank you.
Yeah, and so Yuri, you have test specification and requirements in your Agile picture as well, and can you talk a little bit about generating Agile system test specifications from requirement specifications? Can you do that?
Yeah. No. Generating the test specification documents from requirement specification documents, there are many different vendors who claim, they can do it. With Polarion, of course, you would be able to generate a skeleton or stub of the test specification document, but this is really just very often just to ensure that there is a full test coverage, so you can really ensure that for every requirement you generate a test item that you need later to really analyze and define the testing procedures. So to some extent, of course, we can help with automation of the generation of the test cases for each requirement, but this doesn't really guarantee any better quality, because you need to anyway, make sure that the detailed test procedures really cover the requirements. So from our point of view, the goal is not really to automate the generation of the test specifications, but ensure that the overall process, how you, for example, modify the requirements, ensure that test cases needs to be developed for any single change. And of course, working with Vector to understand, what is the code coverage. So if to give really a proof that all the changes were really tested properly, that's a great help. So instead of focusing on the automation of automated generation of a test cases, it's better really to automate the process, to set up the workflow that all the users are guided through the change management process. So whenever the change needs to be processed, they know they have to update the related tests and ensure that at the end all the results would be immediately accessible in a central place, so you can verify that the results would be fully tested. It doesn't speak, of course, about test automation, and overall we see a great number of customers adopting more and more test automation. I would say that currently it's more than around 30 to 40% of test cases might be really automated with the test automation tools.
Okay, great. Vance, back to Agile here. So within the context of Agile, you have user stories. Typically, those user stories encompass, as the business case wants to utilize something, I want to do this so I can, achieve this goal. And then part of the user story has to do with, okay, what constitutes the acceptance, and how do you show me that it's working? And then, of course, there's also in Agile something called the definition of done. Certainly testability from, considering user stories from a testability perspective and how to incorporate the testability requirements within the definition of done seems like that's two important things to integrating what you're talking about within Agile. And how do you do that?
Very good, very good. So user stories are a truly improved way of writing requirements, or they can be. They certainly should be. The challenge with traditional textual requirements is it's all about context. It takes many, many sentences to convey a thought, whereas in Agile with a user story, it tells really what the user's looking for, okay? Well, it's only as good as the detail of the user story. If we think about the weakness of traditional requirements, high level, low level, that kind of thing, in the context, user stories do solve that. However, it's also easy to forget that the user story needs to be refined over time to really essentially emulate the lower level, the detailed requirements. What we need to do, folks, with Agile is make sure that two different readers of the user story or listeners don't get a different opinion about what the user wants. So the more detail that's added over time to that user story, we keep the same context, we keep the user story label the same, the name of that story, but we add detail to it. When we believe that two different readers or listeners of that user story would have the same understanding of what that user wants, their story, then we can pass on that story to the next generation. So think of it as the ancient Greek storytelling tradition around the campfire, looking at the stars. You don't want a story that changes with each teller, okay? You want something like Homer, the Iliad, lots of detail. That's what we want with these user stories. So what we need is a traceability capability where we can track and improve the clarity of that user story over time, and then correlate the testing aspects. We want two things. Number one, assurance that all aspects of that user story are verified to make sure the implementation matched the story, but then also to ensure that we didn't add any undue logic, or that we could not prove that we did the testing. So we want that correlation. We want that to be done automatically to the greatest extent possible, and we want the test cases to be updated as that story is refined. Remember, the story doesn't change so much. It's about refining the story, okay? We don't change the plot. We just change some of the character attributes of the story, if you will. So again, it's about the automation, the correlation of traceability, and the continuous testing that we use to promote the refinement of the user story over time.
So then,
hope that answered the question. Yeah.
Okay. Yeah. So there's the definition of done dimension. So the definition of done defines, okay, a user story is done when these criteria are met. So I suppose thought should be given in terms of a user story is done when, for example, a continuous test integration test cases are integrated and being tested on a nightly basis or something like that. Is that how you...
Exactly, with one additional caveat. Let's say an optimistic tester thought he was done testing the user story, but that tester could assess how much of that code associated with that story were actually covered by actual tests. Well, there's two thoughts there. Number one, most of the code, truly 80 to 90% of that code should be covered, okay, by the test. But you can only assess that if you spend a lot of tedious manual work, or if you have continuous test in the background with a capability of assessing structural coverage automatically in the background. And that's where the combination of Polarion and Vector really work together. The Polarion aspects update the traceability and manage it automatically, whereas VectorCast, with the managed tool, aggregates those test pass-fail and the structural coverage. So instead of taking a very tedious task to assess that structural coverage and never getting it done, it's done in the background. And that way, a tester who thinks he's done, or she, who's overly optimistic, can look and say, oh goodness, I've only covered 70% of my structures, but I thought I was done. Clearly, I was a little optimistic. Let's at least make sure 90 or 95%, if it's a safety critical device, 100%, okay? But that way we can assure that all that code was actually covered, and then the story is truly finished, the end.
I see. Okay, so this dovetails into the next question for Yuri here. When you're speaking about source code traceability, can you be more specific? Do you link source code files with functions, with the requirements? Is there some automated stuff that can happen there? Can we utilize that within our processes?
Okay, great question. So first, we definitely do not link just the files. Principally, I mean, the most important thing is to really link a change, because you need to make sure that the changes that you made to your source code match the actual description of a change records. So we don't link files, we don't link functions, we link changes. And of course, a change might apply to one specific function or one specific It might be just related to one specific file, but it can also span over multiple files, multiple functions. The one thing is, what is also important to say is that you might have requirements, and to actually plan the implementation of the requirements, you can or you need to track additional artifacts such as some kind of a high-level task, work packages, user stories, and low-level implementation tasks. So typically, the changes in the code are linked to the tasks that are actually linked to the requirement. So for one single requirement, you have the traceability to all the changes that are somehow affecting this single requirement or has affected in the past, and of course, all the changes to the source code itself as it happened during the full life cycle of the project. So to make it simple, it's not just a file, it's not just a function, but it's any kind of a change. If it is small or big, doesn't really matter.
And if the requirements are bigger than just paragraphs, if they're use case definitions, how do you link those with test cases?
Okay. I would say there are different kinds of requirements. We typically call them stateless and stateful. Vance was already speaking about it, that very often the requirements are very context related. So if you have the common requirement specification document, the requirement is just a paragraph in a document. And to really understand the requirement, you need to read it in the context of the specification. This sounds wrong, but what I like on that is that the people are thinking like that. So it's very easy for anyone to just sit down and describe the intended use and describe all the functional requirements as uniquely identifiable requirements. So I'm thinking still that there is nothing wrong about providing this complementary documentation. And then, of course, you have additional user stories that might be detailed by the granular requirements. So you have a high-level user story, and the user story should be doesn't really depend on the context. So I can get a user story and read it by itself. I can have additional design or functional requirements related, linked to the user story that provide all those additional detailed information that Vance was speaking about. Or, of course, it is linked with many other test procedures that helps all the stakeholders to understand the user story better. And the same with the use case. I mean, the use case is, again, similar to the user story, a standalone object that you can read without a context of other use cases in the document very often. So you should track both. I mean, and very often, I mean, they need to be traced together. So the use case diagram with all the use case elements are tracked as a single individual object that is potentially refined or related to many other functional or non-functional requirements. And from traceability point of view, it just requires that you should be able not just to trace a textual requirements, so these individual paragraphs, but also a modal element. So if I have a use case diagram, I should be able to link a test procedure to one particular step in my use case definition.
Great. Again, we have a few minutes left here, so there is still time to ask questions. So I'll remind the audience you can still feel free to ask questions while we have a few minutes here. Vance, top-to-bottom traceability. People understand that. It has to do with understanding that they've implemented the high-level requirements so they can prove it's done. Why should someone be concerned with bottom-to-top traceability?
Oh, that's a great question. Someone's prescient out there. Traditional top-to-bottom traceability simply says, have I implemented all of the requirements or aspects of my user stories? Very good. You're two-thirds of the way there. But the unanswered question is, what about bottom-to-top traceability? Do I have any extra code that doesn't have a reason to be there and in fact is part of a legacy that should be removed? Are there any unexercised functions and why? Shouldn't I at least test all the functions to some degree? And then finally, how good were my requirements? Because look, if I did, or thought I did, terrific requirements, user stories, and terrific tests, but I only have covered 30 or 40% of the structures in that software, what does that tell me? Well, it means clearly my assumption that I thought I had good requirements or good tests isn't valid. I needed better requirements and or probably better tests. So I can only understand that if I have structural coverage and if I have a bottom-to-top traceability. Again, we don't want to do that manually. It's too tedious. So we have an automated tool for traceability. That's Polarion, Yin and Yang, and of course VectorCast to automate the structural coverage to answer that question. So it's not just did we cover all the code and tests. It's is my assumption of good requirements, good user stories, and good test cases valid? Okay, that's really what a software manager wants, the software leader, or a good software engineer. The answer to that question, only bottom-to-top traceability gives that to us.
I see. Okay, great. Well, I guess that brings us to the top of the hour and the end of our today's eCast. Want to thank Vance and Yuri for sharing their expertise on software requirements, test needs, and traceability. We at Open Systems Media, Vector Software, and Polarion also want to thank you, the audience, for attending today and contributing those excellent questions remotely. This eCast will be posted online at the URL shown on your screen within 24 hours, and an audio-only podcast version will also be made available there. You can do a web search with the keywords embedded space e-cast and find all of Open Systems Media eCasts available for download as MP3s. Thanks for attending, and have a great day.